In this session, we'll be discussing about an algorithm. What is an algorithm and the important active areas of research, algorithm specification, and a few examples of recursive and non-recursive algorithms. What is an algorithm? An algorithm is a finite set of instructions written to do a particular task. Algorithm has certain properties like it must have a zero or more number of inputs and must produce one or more outputs, and every instruction in an algorithm must be clear and unambiguous, and the algorithm must have a finite number of instructions, and also if a loop is written it must terminate in a finite number of steps, and also every instruction must be basic enough to be carried out by using a pencil and a paper. And there are four important active areas of research in an algorithm. One is how to devise an algorithm. Designing an algorithm is an art. In order to design an algorithm for a new problem, first we must have to understand the existing various algorithm design techniques and we must be master in that. Then only we can think of designing a new algorithm for a problem. So once you design an algorithm, you have to validate that algorithm manually by using a pencil and a paper, and for all possible combinations of inputs you have to verify, and for the different range of inputs we need to validate the algorithm. Once you confirm that your algorithm is working fine theoretically, then you can analyze that particular algorithm for efficiency in terms of the space and time. Time efficiency is nothing but the time taken by an algorithm to complete its execution, or we can say how much time the algorithm takes to complete its execution. And space efficiency is nothing but the amount of extra space or a memory required by an algorithm to complete its execution. Then finally you can test a program, that is a debugging and a profiling. So you can implement your algorithm in any one of the programming language. And when you compile and run a program, you might encounter a different kind of errors like a syntax error or a logical error. So you can fix up those errors and finally you can execute a program. That is what is called as a profiling. So once you execute a program, you can measure the performance, that is in terms of a time and a space of an algorithm, and that is what is called as the profiling. Now see how we can represent an algorithm. There are different ways to represent an algorithm. So one thing is you can represent your algorithm using a natural language, statements like in English. And then another approach is the graphical representation like a flowchart. And another approach is using the programming language constructs like for, if, while statement, and you write in terms of a pseudocode. It almost looks like your program code, but not exactly a program code. A general programming constructs like for loop, while loop, if statement, those constructs will be used to represent an algorithm. We'll see the algorithms in general can be classified into two categories, that is a recursive algorithm and a non-recursive algorithm. We'll see one of the example of a non-recursive algorithm, that is a selection sort. In the selection sort, we have to arrange all the n elements which are inputted into an algorithm in the increasing order or a non-decreasing order. And there are various sorting techniques, and the selection sort is one such technique. And the basic concept in the selection sort is in the unsorted array, we are going to find out the smallest element and we place it next to the sorted list. That's how the selection sort is going to work. We'll see how the selection sort is going to work. As we mentioned, so this is an unsorted array and we are going to find out the smallest element, that is a 7. So far the sorted list contains a 0 element. Next to that we are going to place that smallest element called a 17. And now this element is a sorted array and the remaining elements treated as an unsorted array, and in that we are going to find out the smallest element, which is 29, and that is placed next to the sorted array. So the first two elements are sorted. Again, in the remaining unsorted array, we are going to determine the smallest element and we place next to the sorted list. And that will continue till all the elements are sorted, or finally a problem size of 1, and by default the element is going to be sorted. Okay, that's how the selection sort concept is going to work. Similarly, if you come to the recursive algorithm, basically there are two types of recursions. One is called a direct recursion, another one is called an indirect recursion. In the direct recursion, say for example, you have a function called a. That function a calls itself. That is what is called as the direct recursion. Whereas in case of an indirect recursion, assume that you have two functions, that is function a and function b. Function a calls function b and b again calls a. That is what is called as the indirect recursion. Now we'll see few examples of a direct recursion. Okay, there is a factorial of n and towers of Hanoi problem and a permutation generated. We'll see one example of that, how to compute the factorial of n using a recursive program. The main definition for the factorial of n equal to n star into factorial of n minus 1. That means you are finding a factorial of n by computing the result of factorial of n minus 1 and then multiply with n. And we know that factorial of 0 is going to be 1. So this is an algorithm. If n equal to 0, this factorial function will return 1. Otherwise, it computes factorial of n minus 1 and n and returns. So here factorial of n is computed in terms of n into factorial of n minus 1. So we are calling the same function factorial with n minus 1 value. So here you can see an illustration. Say for example, we are computing a factorial of 4. Main function calls factorial of 4. We cannot compute factorial of 4 so directly, and we are calling factorial of n minus 1. That is a factorial of 3, and then it is multiplied with 4. Finally, it is going to return the result. So factorial of 4 is calling factorial of 3, and we do not know factorial of 3. So it is going to determine by calling a factorial of 2 and multiplied with 3. And factorial of 2 will be obtained by multiplying 2 with a factorial of 1. Factorial of 1 will be obtained by multiplying 1 with a factorial of 0. So this is the function which is called at the end with a factorial of 0. It will compute this factorial of 1 by multiplying factorial of 0 with 1, and then it returns the result back to the its calling program called a factorial of 1. And factorial of 1 is obtained from the function that is 1 multiplied with 2. So the result will be 2. That will be written back to the factorial of 2. And that gets multiplied with 3, and the result of 6 will be written to factorial of 3. Factorial of 3, that is 6, gets multiplied with 4, and the result is 24, will be written to the factorial of 4. That finally returns the result back to the function, main function.